Magic mushrooms trip your brain out of sync for weeks, a new study finds. So, what we're looking at is changes in the human brain connectivity resulting from psilocybin as seen using an fMRI. Look at the changes here. Once maligned for their psychedelic properties, magic mushrooms are increasingly attracting attention for their same mind altering potential as a therapy for a wide variety of mental health issues. Yet surprisingly, little is known about the diverse neurological effects of the funguses, because mushrooms are funguses, by the way, psychoactive compound psilocybin, making it difficult to predict how the drug might ultimately benefit the community as a medicine. A study led by Washington University School of Medicine psychiatrist Joshua Siegel tracked brain changes in 7 healthy adults before, during, and after taking a high dose of psilocybin, identifying disruptions in connectivity that persist for weeks in some areas of the brain. The findings fill gaps in our understanding of how psilocybin's biochemical influence translates into large-scale changes in behaviors that may help or hinder individuals with different psychological needs. Siegel says these days we know a lot about the psychological effects and the molecular cellular effects of psilocybin, but we do not know much about what happens at the level that connects it to the level of functional brain networks. Magic mushrooms weave their glamour by mimicking serotonin's affinity for the 5-HT2A receptor. The subjective effects are well known, typically inducing euphoria coupled with distortions of self-perception, time, space, sound, and color. Animal models confirm that briefly activating these receptors in regions where they are found in high density, such as the medial frontal lobe, triggers long-lasting effects by loosening hard-wired pathways and promoting new connections. This very plasticity of the nervous system that allows our brain to be adaptable, making psilocybin an appealing pharmaceutical for treating psychological conditions that are stubbornly resistant to change. Whether these same conclusions can be applied to humans, however, is not clear, so Siegel and his team conducted functional magnetic resonance imaging scans on volunteers before they took the generous 25 milligrams of psilocybin. Further scans were done immediately following their dosage and again 21 days later. For comparison, the subjects also received a 40 milligram dose of the stimulant methylphenidate on separate occasions, with a similar series of scans taken. The scans clearly showed significant disruption in the functional connectivity across the brain's cortex after the psilocybin dose. Deeper inside the brain, major changes were also seen, a group of regions most active when we are awake but not occupied with a task, known as the default mode network, DMN for short. Based on previous studies involving rats, the researchers suspected the widespread disruption resulted from populations of nerve cells that typically coordinate their activity falling out of sync, temporarily erasing the unique patterns that give rise to the sense of self. The brains of people on psilocybin look more similar to each other than to their untripping selves, says neurologist and senior author Nico Dosenbach. Their individuality is temporarily wiped out. They don't have a sense of self, can you imagine? This verifies at a neuroscientific level that what people say about losing their sense of self during a trip. Curiously, giving the volunteers a simple auditory visual matching task after their psilocybin dose as they were being scanned seemed to ground their DMN, reducing the severity of disruption. Scans conducted 3 weeks after psilocybin treatment showed the cortex had mostly returned to pre-dose synchronization, yet a region called the anterior hippocampus, which is involved in a range of cognitive processes that involve perception and memory, continue to show a persistent functional change. Connecting what we know about the pharmacology of psilocybin with self-reported and cultural knowledge of its effects within a neurological framework could point the way to treatments that ease depression or reduce post-traumatic stress, or serve as a way to caution against its use in situations where disruption could pose significant risks. We might still be some way off, visiting our doctor for a dose of mushrooms to help us get our minds back in working order, but studies like this get us a step closer to understanding the fascinating relationships between our brain and this magical group of fungi, these mushrooms, these magic mushrooms. The research was published in Nature magazine. It's on Science Alert by Mike McRae. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.